let's introduce the concept of an abstract data type. The data types we've had so far have been what we would call primitive data types. And those would be things like ints, longs, floats, doubles, booleans, and characters, and nothing else. These are the only primitive data types in C++, aside from the ability to turn these into pointers, but we're not going to get to that. And so we've been using some other data types that aren't primitive, and perhaps we'd like to learn to do this ourselves and why you might want to do this. So there are what we would call abstract data types. And the difference between these two is that fundamentally the compiler knows how to handle all of these things. Any sort of primitive data type, there is a representation that is agreed upon that we use in the computer to do this. So for instance, an integer is 32 bits on most machines, and it has a certain way where the first bit is a sign, so it says this is a 0 or a 1, and then the rest of it is just like a standard representation, or you have floats where it's stored kind of like scientific notation, and it's 32-bit, and there's generally an agreed upon way to put this into the computer. And so the compiler knows how to handle it, and it doesn't have to do anything special. However, when we get into things that are more complex, or if we want to define our own types, which we're going to do here in a second, that's where abstract data types come in. These are things that the compiler doesn't inherently know, but we can tell it about, and it can make some kind of data type for us. The kinds that we've used for this have been things like strings. Now, strings are primitive in some other languages, but here in C++, they are an abstract type. We've used things like output streams, or any sort of file stream as well, like an OF stream. And we briefly went over in that bonus lecture about what a vector was, which is also an abstract data type. And so these are things that the compiler doesn't inherently know about. At least most compilers won't. And so we have it defined as a user, being the programmer, how these things actually function. So let's do an example of something like that. Here, let's just say I wanted to create a user class. I'm creating some sort of application where I'm going to have a user base. And so you might think, well, the user is going to have an ID, so I might create an int user ID. And then I might have something like their email or their username, so that might be a string in and of itself, and so that might be their username. And then I might want a user to have their age, and then maybe I'm checking if they're logged in or not, so logged in, let's just say, which would be a boolean, true if they are and false if they're not. Now this is nice, we could all write all of these variables and use them, but the problem with this comes with the fact that what if we have a bunch of users? Then I might need to make this an array, right? So I might declare some kind of array size up here, just make a constant. I'll just call it size, and then make it 10 or whatever, and then make all of these arrays, right? So I can make this one and set it to be size, and then do that, right? And then do the same thing here and make this one an array of the size, and keep going. The problem here is that there's not really a sense of cohesion. All of these things would hopefully make sense to be grouped together rather than stored in a bunch of different arrays that we'll have to keep accessing each array to get that information. So rather than do something like this where we just create a bunch of arrays, it's a better idea to just group all of this data together and then throw it into an array afterwards, or whatever kind of list structure you want. So here I'm going to get rid of all the array stuff that we had. Let's turn this into a cohesive package. The way we can do that is with an abstract data type, and the one we're going to be covering in this class is called a struct. And the way you do this is you just put the word struct, and then you put whatever the name of the type you want to create is. So here I'm going to call it person. Try to make these capital. You'll see sometimes people don't do that. That's the convention that I am used to, and I think a lot of languages use, so I recommend it, is to make these capital. That way you know that they're abstract data types. And then we just put all of the types that we want between the curly braces and then a semicolon. And so what this does is I can now create any given person, or you know what, I might want to call this user, since we said this was specifically for users. I'll call this a user. And so whenever I create a user now, it contains all of this stuff. So if I was to go down later, let's just keep part of this on screen. If I was to go later in the code, and I go into main or whatever, and I declare a type user, which is totally valid, we've now created our own type. So we can use it in the exact same ways that we would use an integer or a float or a double, any of that stuff. It generally is going to work, aside from some fringe cases. So you can't add a user to something or subtract. You have to define that later, which is something we cover in a later course. And you can't also just write it to cout directly. So remember that. You're probably, I see a common example of errors is that people just try to print these directly instead of handling it correctly. But we'll get into that. Right, but we can use it in the exact same way that we can use an integer or a float or a double or Boolean now that we've created it. So if I want to create a user variable, I simply say user. Remember, when we do a variable declaration, it's just the data type that we want and then the name that we want. So, the common structure is to name it the same sort of thing, but I'll just call this something like sample user. And so what this does is it creates a cohesive package that contains a user ID, a username, an age, and a Boolean for logged in, and they're all stored together as a variable called sample user. Which is great. Now we can store things together and be able to kind of know, well, these things all belong to the sample user. And I think this makes it a little bit more readable for the sake of our code. The main reason we do this is for readability. We don't technically need this, right? Like we were saying earlier, we could just make an array of all these things if we wanted a bunch of different users, or keep a bunch of different separate variables and use those instead. But for the sake of our understanding and for the sake of readability in our code, it makes it nice to be able to group things together so that we can attribute these things to a common object. In this case, our object is sample user. So I have some sort of user that's logged in, and this is their user ID, this is their username, this is their age, this is their logged in status. They kind of all have this thing. And this becomes important once we start introducing more and more objects into our code. I might go and create another user and call this like the admin, something like that. And then the admin is going to have their own set of data that's completely separate. We don't have to create a bunch of different variables. So notice that I don't have to write 8 different variable declarations when I do this. I just write 2 users, and it knows each time that they have these 4 variables that belong to a user. So it's very much just a convenience thing. It makes it easy to group together data and to be able to read our code. And now we can keep things separate as well. So here I know, well, this admin variable is going to have a user ID, a username, an age, a logged in status, and the sample user is going to have all those things too, but they're separate, right? So the user ID of the sample user might be, 4, whereas the user ID of the admin might be 0, and then they have, a username where it's admin, and user and that kind of stuff. And so they're all separate. They're all kind of self-contained, and we're able to use them separately and kind of think of them separately. So it makes our thinking process a little bit easier as well. Right, so that is kind of the advantage to using these structs, this abstract data type. Now, the last thing we should address here is how to actually use these. So we've said, okay, they have all these variables and they're all grouped together like this, but we actually need to be able to use them in the code. So here I'm going to do a quick code sample. Note that the one main thing about a struct versus the other abstract data type supported by C++, a class, is that everything is accessible by default. This is the only difference, and that's called public when everything is accessible. So everything in a struct is public by default, and everything in a class is not accessible by default. You have to go out of your way to do it. So that's our main difference. And here we're going to go over how to actually use them. So here I'm going to create a user. We'll just use the same example as above. I'm going to create one called admin. And we know that the admin from earlier has an ID, they have a username, they have an age, they have a logged in status. And the way I can set those is using the dot operator. The dot operator is just a dot after the variable that you want. So here it would be admin dot whatever it is that we want to access. And so the names here just have to match whatever the names are that we gave in our struct declaration. Here my struct declaration has a user ID, so if I wanted to access this admin's user ID, then I simply put admin and then user ID, and now I'm accessing that specific object, being the admin user, their ID, and so I could set this equal to 0. And so I could do this exactly the same way. I could keep using the rest of the variables. I could say, okay, well, their age is 28 or something like that, and their username, oh, whoops, I'm typing the wrong thing. Their username, I think we said, was, I don't know, admin user or something like that. And we could keep going. I think there's only one more variable, but we could set these. And you can use them exactly like you would use any other variable. They just now belong to a cohesive package called admin. And so we can assign to them, we can put them on the right-hand side of expressions if we want to use them. So I could print the age, I could add it to something. But just, like I said earlier, make sure you're not doing something like this where you just put cout and then admin, or whatever file or output stream you're trying to write to. Don't just do something like this, because what does that really mean to print a user? You might have something in your head that makes sense, right? You might think, well, okay, I want to print their name and maybe their ID and all of that stuff. But as far as the compiler goes, right, we said earlier that these aren't things that the compiler understands natively. It knows that they're a collection of things, and it can kind of understand that, but it doesn't know what it means to do printing for something like this. And for the similar operations like adding or subtracting, what does it mean to add two users together? Because I could certainly write that. So avoid just using these abstract data types directly how you would use the data types that you've used in the past, like integers and floats, and just writing them directly to a stream. Make sure that if you're intending to write, let's just say, the username of this admin, that you are accessing it properly. So remember, we say the dot operator, dot, is going to give us any sort of attribute in this. So if I do this, now this is fine, because the admin has a username, and the username is a string, which it does know how to print. And I understand that a string is an abstract data type, like I said earlier, but it is capable of printing it because somebody has written code that makes it understand what it means to print that. And you can certainly do that too. Again, this is a topic covered in a later course. But just a common error I see, and just wanted to address it here first. So this is how we use a struct. It's very nice for aggregating data like this. So this is called aggregation, when you put data together like this. One last thing to mention, I don't think you'll need to use it for this course, but I think it's important. You can also put functions inside of structs. we're just going to use data types for the time being. You can create any variables that belong to that, but you can also create functions that belong to these, and you can access them in exactly the same way. And so an example that we've maybe seen of that would be something like a output file stream or an input file stream. I think an input file stream might make more sense. And so we said this is an abstract data type. Somebody has written code somewhere. When you do include fstream, it puts all their code into your code so that you can use it. And so when you do ifstream, it creates this abstract data type that exists. It's going to have all of these attributes that you can use, and it also has functions that you can use. And you might know what I'm talking about here if you've seen it already. There's a couple that we've been using. So the big one that you probably remember is open, right? So if I opened a text file, InFile is an abstract data type, and it has a function called open. And I think this is a good example of where this comes into play. You're able to use these functions on specific objects. So rather than just creating some nebulous function like we've been doing before, you can tie it to an object and have it operate on it. So when I do infile.open, it opens just this file. It doesn't affect any other kind of data type that is the exact same thing, and I also can store it along with everything. So it makes sense that a file has an operation called open, so I'm able to store that as well, to aggregate that into the abstract data type so that I can associate actions with a data type as well. The other function that you might remember from files would be something like end of file. So I might write something like this, right, where I say while infile dot end of file, and then put a not, and the function end of file then belongs to the ifstream struct. Whenever I use an object that is that struct, like an infile here, then I can check for the end of file of just that specific file. It's another example of where we can kind of put a function inside of a struct and then associate it with it. That way there's some sort of meaning. I think that about does it for our abstract data types. In the next and probably last video of the semester, we're going to take a look at an example program that uses abstract data types, and then we're going to put them into an array. That way we can organize them.